So the first one, going from rods to inches. We're going to put 4 rods over 1 to make it a fraction. And in a conversion factor, we're going to put rods on bottom so that they cancel out. But do we have a direct conversion from rods to inches? No. But we can go from rods to feet. 1 rod is how many feet? 16.5. So the rods are gone. Now I could multiply this out if I wanted to and get an answer and then convert it from feet to inches, but I'm just going to keep going here. I'm going to get rid of feet and go to inches. I know what's the relationship between feet and inches? 1 foot equals 12 inches. So now the feet will cross cancel out. So to go from rods to inches, I have 4 times 16.5, which is 66, times 12, which is 792 inches. Very good. So 4 rods is 792 inches. How many of you had that? Perfect. 7.2 meters going into centimeters. For the metric, it's just a matter of the movements on the chart. So from meters to centimeters, it's meters, decimeters, centimeters. 2 spots to the right, correct? So my decimal point has to do the same thing. 2 spots to the right, so I have to add a 0. 720 centimeters. Millimeters to centimeters, same thing. On the chart, to get from millimeters to centimeters, it's 1 spot to the left. So my decimal point has to go 1 spot to the left, giving me 5.7 centimeters. Any questions so far?
I already got number 4.
Number 4 is one that, yeah, I'm expecting people to have some issues with. 4 inches per second, I'm going to write, or 40 inches per second, I'm going to write it as this, 40 inches over 1 second. Now I have to change the inches, so I'll put inches on bottom, changing them to feet, so I'll put feet on top. 1 foot is 12 inches. So the inches cancel out. But that would be feet over seconds, and I want feet over minutes. So I'll put seconds on top so that they'll cancel out with the one on bottom. And change it to minutes. 1 minute is 60 seconds. So I cross off the seconds. They cross cancel out. One's on top, one's on bottom. So now on top, I have 40 times 60. Well, 40 times 1 foot times 60 is 2,400 feet. On bottom, 1 times 12 times 1 minute is 12 minutes. If I divide that out, that is 200 feet per minute. How many of you got that? Anybody? Okay. Well, that's okay, because that's where we're going to start off today, with conversions that look like that, where we have dual units. For example, if I were to tell you guys that I can throw a baseball at a rate of 90 feet per second, how many of you would believe me? That standing at first base on a baseball field, I throw the ball to home plate and the ball gets there in 1 second. Do you guys think I can throw that fast? No? Is it that fast? Well, how are we used to seeing speeds expressed? Miles per hour. So to make this conversion, I'll make this 90 feet over 1 second. I have to get rid of feet, so I'll put feet on bottom. What do I want to change it to? I want to go miles per hour, so this is going to be miles. So 1 mile is 5,280 feet. So the feet cross cancel out. But now I'm in miles per second, which I don't want. So I got to get rid of seconds. I don't have a direct conversion from seconds to hours, so I can go from seconds to minutes. 1 minute is how many seconds? 60. So now the seconds have canceled out, but I'm in miles per minute right now. So I want to get rid of the minutes. They go on top, so they'll cancel out with the one on bottom. I'm going to go to hour. 1 hour is 60 minutes. So now my minutes are gone, and I will have miles over hours, which is what I want. 90 times 60 times 60 is what? 324,000, I believe. Miles. Over 1 times 5280 times 1 times 1 is 5,280 hours. Yes? So we divide that out. 324,000 divided by 5,280. 61.36 miles per hour. I'm pretty sure I can still throw that fast. It might take me a while to warm up. Pretty sure I can hit 60 miles an hour. So now you think about that. That's 90 feet in 1 second. How far is it from home plate to, from Fisher's Mound to home plate? 60 feet, 6 inches. They're throwing a lot faster, right? They're throwing 90 miles an hour to 100 miles an hour now, some of them. That ball gets from the pitcher's hand to the home plate in about 0.4 of a second.
And you got them catchers that can throw from home to second or even going.
Well, yeah, the good catcher can throw from home plate to second base in just over 1 second in the air.
That's 180.
Nope, that's 120.
120.
Yep. That's like 126 is something that it comes up to be. Okay, so let's take a look now. We want to look at some of our other units here. For example, let's say that you have a pump that is going to, let's say a little bit different. Let's do it combining our units in another way here. Let's take something like 8 feet 7 inches plus 3 feet 2 inches. When I go to combine units, just like with whole numbers, I'm going to start on the right and work my way back to the left. Just like with whole numbers, I can carry and do whatever. I'm going to line up my columns. I can only combine inches with inches and feet with feet. 7 inches plus 2 inches is 9 inches. 8 feet plus 3 feet is 11 feet. Now, of course, it doesn't stay that simple. We run into things like this: 7 foot 9 inches plus 4 feet 8 inches. We start on the right over here. 9 plus 8 is 17 inches. What's the problem with that? It's more than a foot. So I can get out a whole foot from there. How many inches would be left? 5. Good. A foot takes out 12 inches, so 17 minus 12 leaves us with 5. So I'm going to keep the 5 inches and carry the 1 foot. 1 and 7 is 8, plus 4 is 12 feet. So we get 12 feet, 5 inches. Make sense? Or we could have 3 rods, 4 yards, plus 7 rods and 5 yards. So we're starting on the right here. 4 yards and 5 yards make 9 yards. Is that bigger than a rod? Yeah, how many yards are in a rod? 5.5, right? 5.5. So out of 9 yards, how much would be left if I take a rod out of it? 3.5, 3.5. So we're going to keep our 3.5 yards and carry our 1 rod. 1 and 3 makes 4, plus 7 makes 11 rods. So 11 rods, 3.5 yards. Or I might have 5 yards and 2 feet plus 3 yards and 2 feet. What happens when I add those up? 2 feet and 2 feet make 4 feet. Of course, that is bigger than a yard. So that's 1 yard, and how many feet are left over? 1 foot. So we keep the 1 foot, we carry the 1 yard. 1 and 5 makes 6 plus 3 is 9 yards. So 9 yards, 1 foot. Any questions there? Not so bad, right? Subtraction works the same way. We can have 8 feet, 7 inches, minus 3 feet, 5 inches. Again, just like whole numbers, we start on the right and we work our way back to the left. 7 inches minus 5 inches is 2 inches. 8 feet minus 3 feet is 5 feet. Again, it doesn't stay that simple. I can have 7 feet, 2 inches minus 4 feet, 11 inches. I go to subtract. 2 minus 11, obviously I can't do, so I have to borrow. The 7 feet becomes 6 feet. Does this become 12 now? No. I added a foot to it. I borrowed a foot, which is 12 inches. So 2 plus 12, this is now 14 inches. So 14 minus 11 is 3 inches. 6 feet minus 4 feet is 2 feet. So 2 foot, 3 inches. What if I have 5 yards, 1 foot minus 2 yards, 2 feet? So at 1 foot minus 2 feet can't be done. Borrow from my 5 yards. This is now 4 yards. What's this become? Yeah, I borrowed a yard, which is 3 feet. So 1 plus 3 is now 4 feet. So 4 feet minus 2 feet is 2 feet. 4 yards minus 2 yards is 2 yards. So 2 yards, 2 feet. Or, excuse me, we can have 7 rods, 2 yards minus 4 rods and 5 yards. A little bit more complicated borrowing here. Can't do 2 yards minus 5 yards, so I borrow from the 7 rods. That's now 6 rods. What's this going to become? Yeah, 1 rod is 5.5 feet. So I add 5.5 and now at 5.5 yards, I should say. So I add 5.5 and now I have 7.5 yards. 7.5 minus 5 is 2.5 yards. 6 minus 4 is 2 rods. What do you think? Not terrible? It sucks? What if I have something like this? 8 feet minus 3 feet, 7 inches. Well, the first thing I'm going to have to do is set it up vertically. I have to make sure I line it up. 8 feet, the 3 feet go underneath the 8 feet. 7 inches are going to have to go over here. Just like I did with decimals, it helps to fill in 0 inches there. Fill in that place value. Obviously, I can't take 0 inches minus 7 inches, so I do still have to borrow. This becomes 7 feet. This is now, 0 plus 12 is just going to be 12 inches. So now I can subtract. 12 inches minus 7 inches is 5 inches. 7 feet minus 3 feet, 4 feet.
The first thing is if I see a problem like that, I just want to turn all the inches.
You can change them into all inches and subtract. It's just a little more work. But if it's easier for you, some people do that. When we multiply, there's 2 different types of multiplication. Remember, when we add or subtract, we have to have the same name. So when I'm adding or subtracting, I have to have feet and inches that I'm combining. That's why we had to add in the 0 inches here, so we had something to combine it with. When we multiply or divide, we do not have to have the same name. For right now, we're not going to look at multiplying feet times pounds or anything like that, but we are going to look at multiplying a measurement by what's called a scalar. A scalar is just a counting number. So if I have 3 feet 9 inches, and let's say I'm going to need 6 pieces that size, I'm going to multiply it by 6 to get a total length that I'm going to need. And like you said, Scotty, you could change that all into inches and multiply it out and then reduce it back down. But again, that's a little extra work. We can multiply it just like this. Just like any other multiplication, we'll start on the right and work our way back to the left. 6 times 9 inches. 6 times 9 is 54, so that's 54 inches. Now there is definitely enough there to make a whole foot. In fact, I can make how many whole feet? 4 whole feet. 4 feet, 4 times 12 is 48 inches. So how many inches do I have left over? Yeah, 54 minus 48 is 6 inches. So I am going to keep my 6 inches and carry my 4 feet. 6 times 3 feet is 18, plus 4 is 22 feet. So we might have 5 feet, 7 1/4 inches, times 9. Seven 1/4 times 9 is 74 1/4 inches. Are there enough inches to make a whole foot? How many whole feet? 6 feet. 6 feet is how many inches? 72. 6 times 12 is 72. So out of the 74 1/4, there's how many left over? 2 1/4 inches. Good. So I am going to keep the 2 1/4 inches. Carry the 6 whole feet. Now 9 times 5 is 45, plus 6 is 51 feet. So if I have pieces that are 5 feet, 7 1/4 inches, and I need 9 of them, that is a total of 51 feet, 2 1/4 inches. If I have something that's 5 yards and 2 feet, I'm going to multiply by 4. I need 4 of them that length. My total length will be, well, 4 feet times, or 2 feet times 4 is 8 feet. Can I get a full yard out of that? How many feet are in a yard? 3. I can get 2 yards out of that. 2 yards would be how many feet? 6. 2 times 3 is 6. So that means there's 2 feet left over. So we're going to keep the 2 feet, carry the 2 yards. 4 times 5 yards is 20, plus 2 is 22 yards. 22 yards, 2 feet. So I have 3 rods, 4 yards times, oh, let's go 7. 4 yards times 7 is 28 yards. Which is, again, more than enough for a whole rod. If I do, I'm going to show you a trick. I'm going to take my 28. How many yards are in a rod? Not everybody at once. 5.5. Very good. So we take 28 divided by 5.5. That's 5.09. So that's saying we have 5 rods from that. Now what I'm going to do is I'm going to keep this in my calculator. I'm going to subtract off the whole number, the 5. I'm going to subtract the 5. Then I'm going to multiply it back by 5.5, 5.5. It gives me 0.5. What that's telling me is I had my 5 whole rods, and I've only got 0.5 yards left over. So I have 0.5 yards. I'm going to carry my 5 rods. 7 times 3 rods is 21, plus 5 is 26 rods. So 26 rods and 0.5 yards. Any questions? So that's multiplying a measurement by a scalar. And again, you could have turned this all into feet and multiplied it, reduced it down. You could turn this all into yards and multiplied it and reduce it down. It's just less work if we stick with the dual units. So that was multiplying a measurement by a counting number or a scalar. If we want to multiply a measurement by another measurement, let's say we have 5 feet 3 inches and I want to multiply by 3 feet 6 inches. Well, in standard measurement, we have this dual unit thing going where we will do feet and inches together, or yards and feet, or rods and yards. When we do that, though, for addition and subtraction is okay. For multiplication and division, it really complicates things. We could multiply this, but if you recall from when we did the mixed numbers, the 6 inches has to multiply the 3 inches, but it also has to multiply the 5 feet. So we'd end up with a unit, a foot-inch, which is actually a real unit. It just doesn't have any applications anymore. And generally, when we're multiplying areas, we're multiplying 2 lengths, we're looking for an area. We're looking for either square feet or square inches, not feet inches or mixed units. So when we're multiplying 2 measurements, we try to get rid of the mixed units. So we either want to change it all into inches or all into feet. If I'm going to change this all into inches, I have to change my feet into inches. So it's 12 inches in a foot. So I'm going to take 5 times 12 is 60 plus 3. So that's 63 inches. I'm going to do 3 times 12 is 36 plus 6 is 42. So that's 42 inches. 63 times 42 is 500. No, that's off. 63 times 42. 2646. So 2,646. Now you have to multiply the inches, the units as well. Inches times inches are square inches. So 2,646 square inches. If I wanted to change this all into feet, the way I would do it is just this. There's 12 inches in a foot. So this is 5 3/12 of a foot. Or 5.25 feet. This is 3 6/12 of a foot, or 3.5 feet. So 5.25 times 3.5 is 18.375. And feet times feet are square feet. Now a little foreshadowing to our next class here. If I multiply that by 12, I should get the square inches, right? There's 12 inches in a foot. 18.375 times 12 does not give me my 2,646. Nowhere near it, is it? Multiply by 12 a second time, however, I get there. The reason for that is this is not feet and inches. It is square feet and square inches. And we'll look at that next class as to how that changes the way we do those conversions. Let's look at division with our standard units. When we go to divide, when we divide something, same type of thing, we'd want it in single units if we're dividing 2 measurements. So I'm going to look at some simple ones. If I have 18 feet divided by 3 feet, what do I get? Well, 18 divided by 3 is 6. What are my units? They're not feet. They're nothing. What this would be is if I have something 18 feet long and I want to cut it into pieces 3 feet long, I get 6 pieces. There's no units on that. It's just 6. Feet divided by feet divide out. Now I could have something with an area of 24 square feet. I'm going to divide it into 2 foot lengths. How long is each of them going to be? Yeah. 24 divided by 2 is 12. Square feet divided by feet is just feet. So there I would still have units on my answer. Or if I have 32 feet divided by a scalar of 8, then I'm going to divide the numbers. 32 divided by 8 is 4. There's nothing to divide the feet, so the feet are still there. So if it's just a single unit, it's not so bad. But we can still have our dual units. We might have 27 feet, 8 inches. We want to divide it into 4 equal pieces. 4 goes into 27 how many times? 6. So that's 6 feet. 6 feet times 4 is 24 feet. So we subtract, there's 3 feet left over. Now this is where we normally bring down the next number, but before we do that, I've got to turn my feet into inches. So we have to change that feet into inches before we bring down the 8 inches. So 3 feet, 3 times 12 is 36 inches. Then we bring down the 8, 8 and 36 makes 44 inches. So now 4 goes into 44 11 times, that's 11 inches. There's nothing left over. So 27 feet, 8 inches divided by 4 is 6 feet, 11 inches. So I might have 17 feet, 5 inches divided by 8. So 8 goes into 17 feet twice. That's 2 feet. 2 feet times 8 is 16 feet. I subtract, I have 1 foot left over. What do I have to do now? Convert that 1 foot into 12 inches before I bring down my 5 inches. 5 and 12 make 17 inches. Now at this point, since there's nothing, this is the last unit here, I don't want to do a division and remainder. I want to just flat out divide it out. 17 divided by 8, I can make it into a fraction. 17 over 8, that's 2 and 1/8. So it's 2 and 1/8 inches. Get confused?
Look confused? How do you go from 17 inches to 2 and an 1/8 inch?
Because it's 17 divided by 8, right?
Oh,
So 17, I just make it into a fraction.
My bad.
17 divided by 8. Now if I get into the metric units, it's a lot simpler. Because the metric system does not use this dual unit stuff like the standard system does. You will never see something listed as 3 meters, 27 centimeters. It would either be listed as 3.27 meters or, 327 centimeters. And because it's so easy to convert between them, there's no need to do the dual units. It's always a clean conversion. So if we're ever doing an addition, subtraction, multiplication, division, where we have different units, we just need to change one of them. Like if I have 2.4 meters plus 430 centimeters, 430. I either have to change the meters into centimeters or the centimeters into meters. To know which one, I need to know what I want my answer in. So let's say I tell you I want the answer here in centimeters. So the 430 centimeters is not going to change. The 2.4 meters has to change to centimeters. What's that going to become? 240. 240, very good. So now I have the same units, I can just add them together. 240 plus 430 is 670 centimeters. Subtraction, same thing. I might have 52 centimeters minus 320 millimeters. Let's say I'm told I want my answer in centimeters again. Which one has to change? The millimeters. So the 52 centimeters stays the same. This becomes how many centimeters? 32, right? Millimeters to centimeters is one spot to the left. I just have to move it over one spot. Okay. So 52 minus 32 is 20 centimeters. You'll get used to it. You just got to memorize the chart. So then, multiplication and division, same way. We either multiply or divide by a scalar, a counting number, or another measurement. If it's another measurement, it has to be in the same units. If I have 42 meters divided by 6, well, that's just going to be 42 divided by 6 is 7, and we keep the meters. If I have 30 centimeters divided by, oh, I don't know, 15 millimeters, now there's a problem. They're different units. Now here, I'm not going to specify what I want my answer in. And the reason is it doesn't matter. If I go with centimeters, this would be 30 centimeters over 1.5 centimeters, correct? 15 millimeters is 1.5 centimeters. That divides out to be 20. What's units there? None. Centimeters divided by centimeters divide out, right? If I went millimeters, the 15 millimeters stays the same. 30 centimeters becomes 300 millimeters. That divides out to make 20. So when I'm dividing, it does not matter what I want my answer to be in. If there's both measurements, the measurements are going to divide out. When I'm multiplying, it's a little different. If I have 4.2 meters times 210 centimeters, I do need to know whether I want my answer in meters squared or centimeters squared. So let's say I tell you I want my answer in meters squared. So I'll keep the 4.2 meters. This becomes how many meters? 2.1. 4.2 times 2.1 is 8.82 meters squared. Simple enough? For today, it does. In your packet, page 237. Yesterday you did 1 through 12. Today we're going to do 13 through 24. And on page 265 of that packet, yesterday you did 6 through 14. Today we're going to do 15 through 22.